Okay, so how do we advance this analysis? Let's take the original data set and we'll just paste. Okay, and we'll now say, look, we don't know exactly the relationship, okay, because, or maybe it's not possible to get the exact relationship. Maybe there is some kind of error in measurement of variable, maybe there's some kind of imperfection in terms of observation of values. And let's say, so what we could do is we could say, okay, let's take these values again, and we can do copy and paste special values, and we hit OK, and we'll just change marginally. So this might be 7.5, and we'll come down here and say 23.25, and we'll increase this one to 39.75, and then maybe reduce this one, last one, 53.25. Okay, so 53.25. Okay, so 2 and 3 no longer really hold here, right? They might be close to the correct parameters, but we do have an issue if let's say we assumed we have the values are 2 and 3. When we generate the fit, y fit, how do we generate the fit? It would be equal to, let's have a look at this, it would be equal to A F4 plus B F4 multiplied by X. So, okay, let's take that value and we pull it down. Okay, so we say with error. Okay, in fact we might just think of this as the linear relationship, REL, with error. So what we've basically done is taken these initial values and then mixed them up a little bit, or added a little bit, subtracted a little bit from the y, so we don't have a precise relationship. Okay, so let's just check here for a second. So A 14, 23, and so on. So we have the same set of values as what we would have had here, but the true values differ. Now what's the error? The difference between the two equal to the fit minus the actual, or we can go actual minus the fit, might be better. So the actual y minus the fit, and so we have a negative value here, and some are negative, some are positive, mainly positive. Okay, so let's do error squared, and let's take each of these error values to the power of 2. Okay, and pull down, and now we can sum these values, so sum. Okay, and we could do what we did before. We could say, using the solver, okay, let's go to data, solver. Now we are going to say, let's take the sum of the errors, right, and we're going to set to a minimum by changing the reference by changing A and B. Okay, so the reference values we have for A and B, we're saying keep changing these values, search iteratively to find values for A and B that minimize K12, keeping in mind that K12, right, is this value here. Okay, so let's just solve and hit OK. And now we have 1.7 and 3.05. Okay, let's take the same set of values again, copy and paste. So paste special values, hit OK. Right, and what we're going to say is using the linest estimation, linest. Okay, let's take our y values, the dependent variable. We'll take our x values, the x array. Do we want statistics? Do we want a constant? Yes, we do. Okay, so that's our estimate for A. And do we want statistics? Other statistics? Yes, we do. True. And okay, hit return. Now we only have one value here reported. I want all the output from this array. So in order to generate that, we come back up to the function. We've highlighted the cells we want to fill, and then we go Control Shift Enter, and it fills up. Now pay special attention to here. What do we have? Are the values the same as before? Well, using the solver, let's copy and paste and put back in here. Using the solver, right, we found that, let's copy, paste special values, just values. We found that A was equal to 1.7, that's our A, and that B was equal to, in this instance, 3.05. Okay, so we're getting the same correspondence. Okay, so A is equal to 1.7, B is equal to 3.05. Can we remember? Okay, so maybe linest, and with error. So we can see that the relationship here, the values we've estimated for A and B are the same as the values reported here using the solver. Okay, so okay, and we can check this then against another kind of linear estimation package.